Everyone, and I hope your day is fine. Can anyone hear me online? Good evening, Paul.
Good evening, sir.
Okay. It's nice having you again tonight.
Thank you, sir.
All right. I would like to start this evening. We are already 5 days, 5 minutes behind the schedule. But I believe we can continue. Why others join us? The presently I have online Bravo, Multimedia, Moses, and the Evidence Olakoye. It's nice having you on this evening. I would like to start by reminding us what we did last week, which was on equalization for digital mixing console. And I believe everybody that was online gained one or two things. But tonight, I would like to move further so that we don't waste much of the time into the topic for tonight. Last week, I think we paused at if I'm right, those that are with me last week, this is where we pause and try to navigate my PowerPoint for you to be able to see where we stop. Yes. Can somebody remind? I think this is where we stopped last week. Yes, we spoke about fixed equalization and we stopped fixed frequency equalization. That's where we stopped last week. For tonight, for those that are here and I believe everybody can hear me. Those of us that are online, I believe you can hear me.
Yes, you can hear you, sir. I can hear you.
Okay. All right. Thank you for that.
Yes, sir. We can hear you. I'm following.
Okay. Good. So last week we stopped at this fixed frequency equalization, and the fixed frequency EQ is so called because it operates at fixed frequencies, usually selected from two, high and low, 3 high, mid, and low, or 4 high, upper mid, lower mid, and low range of frequency spectrum. Typically, the high and the low fixed frequency EQ on console are 7 EQ. This is just the type of EQ we have on an analog mixer. I think I explained this last week. The one we have on an analog mixer, where you have your gain. After your gain, you have your high, you have your mid, and you have your low mid, or you have your high. Some mixer have only high and low. Some mixer have high and mid and low. While some have 4 high, upper mid, lower mid, and low. for those of us that we do analog, we use analog mixer, you agree that those are the free frequency equalizers. A fixed frequency EQ has a preset bandwidth and a range of frequency on either side of the center frequency, selected for equalizing, that is also affected. The degree of amplitude to which these frequencies are modified from bandwidth curve. So it means that when you go anti-clockwise, you are cutting down on that particular frequency, whether high, whether low or mid. But if you are going on the higher one, you are going clockwise. Let me use that word, clockwise. If you are going clockwise, then it means that you are on the fixed increasing. Yes, you are increasing the altitude. That's the amplitude. Let me use the word amplitude of that particular knobs that you are dealing with on the frequency. Now, moving forward for tonight, graphics equalizer. This is very, very common. Very, very, very common. We find it all around us. As engineers, we use it most of the time. We have different bands. We have the one that come with 32 graphics band. We have the one that come with 16 graphics band. We have the one that come with 32 double, left and right graphics band. We have the one that come with 32 single. And we have even 16 that is also double, left and right. And we have 16 that is single. Sometimes we have 8, left and right, making 16. So the graphics EQ is type of fixed frequency EQ. It consists of slide. Just as I've told you, it consists of slide. You can see the picture beside me here. These are the slide. You see where my mouse is moving? These are the slide. These are graphics EQ. Where you slide up, see where my mouse is presently on 16K. And if I slide this 16K up, it means I'm gaining up by some dB towards plus 12 dB here. And if I cut down, then it means that I'm also reducing or cutting down towards minus 12 dB on this frequency, that's 16K. And also for 8K, and we have for 1K, 2K, and also for 32 hours. Now, looking at this, it consists of slide instead of rotatory. That's just the difference. The one I told you about frequency is the rotatory one, the one on our mixing console, analog mixing console. Controls that boost or attenuate selected frequency. Just as I've made example here, I just mentioned selected frequency like 16K and 8K to boost. It is called graphics because the position of these controls give a graphics representation of the frequency curve set. The idea is that you can set any frequency response curve you like and not necessarily symmetrically in the mid-range, as it is with a conventional resonant EQ. And when you have set the graphics EQ the way you like it, the position of the knob shows a graph of the frequency response. In fact, the supposed graph is merely an approximation between the bands overlap and interact with each other. However, even an approximation is useful. You can glance quickly at a graphics equalizer and see what kind of curve it is set to. So, with what it just been explained there, you can have it your slide, this slide, depending on which frequency you want to treat. Maybe your voice at 1K, 2K, you want to treat your low, mid at maybe around 250 to 125, or your low end at 64 to 32. This will give you a graphics representation of how your EQ is being worked on. And I believe that is something that is very, very commonly used. I don't think there's any other engineer that is not familiar with this graphics EQ. Moving forward, we have parametric EQ. Parametric EQ. As a much more precise tool, a parametric EQ allows you to manually select the exact frequency you wish to change. You can see how wide a bandwidth you want to affect and the level of change you want to apply. With a parametric, you can select a slice of frequency spectrum as narrow as 1/10 of an octave or more. This type of EQ is found on digital console. You can see it here. If you have any digital mixer, this is how the EQ representation is. So you can narrow it. So parametric EQ is mostly found on digital mixing console. Some, like TF5, the one we are using as a litmus test case study, they have screen touch, in which you can touch on the screen and drag up, see where my mouse, and drag up the attenuation or cut down or boost or widen out, just like they have explained here. It makes you to get a precise, let me use that one, it makes you to work with a precise frequency more. So this is a EQ that is most achievable on a digital mixing console. Now, like the graphic equalizer, each frequency can be increased or decreased, which is cut or boost, by plus or minus 6 dB or plus or minus 12 dB. However, a parametric EQ can also control the center frequency. So what do we mean by a center frequency? The center frequency is the one where you have your frequency at 0. Like this now, I have my center frequency. There's some frequency here where my mouse is moving. This should be at around 1K, and you can see my center frequency is on 0. So it gives you a precise center frequency. 0 is your center frequency here. And from here, I can either boost the attenuation or cut my attenuation. I can do that for any frequency I selected. I can narrow it, I can widen it. A parametric EQ also controls the bandwidth of each or range of each control. A parametric equalizer can vary the bandwidth or range of control by making it affect wider or narrower depending on needs of the person taste. Yes. So it depends on your hearing system, how you want it to be. It is wider, it is narrow, or you don't want it to spread to some other frequency, you just want to narrow it in a particular, maybe 1K or 500 or 300 hertz. And if you are working at maybe about 8K, you want to make sure that your voice standard, you are working at around 4K, you can narrow it to make sure that that particular frequency is what you want. It won't shift to other frequency side, either left or right. So a parametric EQ is more precise tool that is used and mostly found on digital mixing console. Now, cautioned, equalizer is useful for making both corrective and creative change of the sound. I want to repeat it again. Equalization is useful for making both corrective and creative changes to a sound, but it needs to be used with care. That's the caution. You have to be very careful. Look at the picture here. I deliberately brought this picture. Can you see the picture I'm moving my mouse on? Can you see the force equalizer on this band? The way it's curved. I don't know, some of us, we used to set our EQ like this. I've been a victim too. I've done it before. So I'm not castigating anybody. Excuse me. I will repeat that again. Sorry. I'm not castigating anybody. I've been a victim of this type of equalization on my EQ, graphic EQ. Cough like this. It doesn't make sense. What am I subtracting? Which frequency am I dealing with? Or I'm just doing a pattern or a design. When I started as a sound engineer that I don't know how an EQ is being used, I fall victim of doing my thing. Now, you do see where how my mouth is moving. I fall a victim of this because I don't know which frequency I'm dealing with. So you can see the second one is flat at center frequency of 0 dB. See my mouse moving on the straight file. So which frequency do I want to deal? I believe that after this training, you should be able to know that the first thing on your EQ must always be on the center frequency. Before you do anything at all on your graphics EQ, you have to maintain the status quo of a center frequency 0. Now from here, when the band start playing, you now begin to know which frequency do you want to handle. Okay, for example, now, just like I've mentioned, I want my vocal to stand out. Where am I working out? I'm looking at 4K. Where is 4K here? This is 8K. This is 4K. So if I'm working and I want my vocal to stand out, I will have to push this up. And you see the way my mouse is moving, gaining attenuation. So if I'm okay with that voice, I can look at, okay, I want to increase some sign of presence. Let the presence, the sibilance, I want to hear more of the voice sibilance. I can move towards my 8K, yeah, and push it up. Because those are the area where it rises. Now for hi-hat, my hi-hat is sounding too harsh. I don't like the way the hi-hat, the microphone is speaking it, is too harsh. Where can I go? I can look at something like the 16K here, and I can come down and cut down my hi-hat because it's too harsh. So if I'm looking at something that I want a basic, I want it to be more of bass, I move towards my 50 here or 63, I can put my 63 up a bit. I feel the bass of the system. Now, I'm not so satisfied with it. I want to clean up the bass very well. I can move towards 50 and increase it also. I can move towards 40 and increase it also. Now, I want my bass to be more tightened and cool. I can come to this 25 Hz or 20 Hz and cut down to make it clear so that it will not be too rumbled. So that was why I was telling you that your frequency range as an engineer, you cannot overemphasize it that you don't know. If you don't know frequency range as an audio engineer, then you are not ready to work with audio. Because these are what we work with. We work with frequency range of from 20 kilohertz to 2,000. Let me use 20,000 hertz. 20 hertz to 20,000 kilohertz. So we are working with 20K to 20 kilohertz. That's 20 hertz to 20 kilohertz. So that frequency range, you must be able to know the frequency at which your data is sounding, and you must be able to affect it there. If you don't know the frequency range of where kick is, it is very difficult for you just to push any button on this equalizer. If you don't know where the frequency of your cymbal, I'm not talking of hi-hat, crash and cymbal, falls within this range, it will be very difficult for you to use this EQ. If you don't know the frequency at which your floor tom-tom, the floor tom-tom drums fall in within this frequency range, it will be very difficult for you to mix, even though there is mic on the drum, to get a good mix for your floor tom-tom. So you can see that we cannot overemphasize the use of equalization for both corrective and creative changes of sound.